Hello and welcome back in the IBP series powered by Camelot. Today, use case number 3 about the Optimizer time series. It is all about managing Overflow DC's Overflow Warehouse. Let's see that right away. We wish to outsource some storage space outside the company. In this case here, we've got still a demand which is seasonal, which forces us to anticipate the production because on the other hand, on the factory, we have a production limit. Therefore, we need to anticipate the production and therefore create a stock build. Okay. As per normal, we deliver the customers from the main warehouse, which is delivered itself from the plant. But during the pre-build period, there is not enough storage space on the main warehouse. Therefore, we wish to push out the goods, the extra goods, on this overflow warehouse. And then later, when the demand rises, like here, then the goods are forwarded back to the main warehouse in order to be delivered to the customer. So we see here storage limits on the main warehouse, production limits on the production plant, and then here the outsourced storage location. To do so, we need to say the system, to instruct the system that yes, please use this transportation lane to the factory anytime you can. And that's why it's a very cheap transportation lane. And please, whatever you can deliver to the main warehouse, do until you reach a limit. And when the limit is reached, then yes, use possibly this other alternative transportation lane to store in the overflow DC, but it's going to cost you a little bit more, like here with 1,000. Therefore, the system will always prioritize to store here instead of going and using this one. Let's see that now in the system. Just for you to know, this scenario seems to be simple, but you have to maintain a lot of master data, like the storage resource on the 3 locations. You have to also assign each product to the storage resource and define to which limit you will limit the storage space on this location, this one location as well, and possibly this one. Although this one we consider it's infinite storage capacity, so that we are not in trouble when we do the planning. Let's see that in the system. So in this scenario, about the demand, there is not so much change. In fact, we have a demand, okay? And then the system will answer with total customer receipts. Currently, again, I've run the heuristics to show you that everything is covered nicely. Let's see now on the production side what is happening. So here on the production side, we see that we have again a low demand period with no utilization, then extra utilization, and then no utilization or very little utilization, where we see we easily exceed the capacity. Currently, this one is for the tool resource. If I select only the one we are using, then we see it's really an actual overload. Okay. Let's see that from the inventory perspective as well. From the inventory, it's not surprising, we are running heuristics infinite, serving on time any demand requested. Therefore, no left inventory in the network. We see here the 5 products we are following with the 4 locations. Again, local DC serving the customers, the local DC 1 and 2, which one can be delivered from the factory or from the original DC in our case, in this new case. Let's see also the capacity from the storage perspective and from the handling perspective. For that, I'm using the logistic capacity template of our solution, SCM Lab at Camelot. So where you can see the transportation capacity, this is not the focus for this current scenario. We see the storage capacity, we see also the storage capacity here, which currently for those storage capacity, no utilization. Why? Because there is no stock left again on those locations. Therefore, no capacity, storage capacity utilized. And from the handling perspective, of course, we are receiving and shipping products from the different locations. Therefore, there is some handling consumption, as we can see here with, well, it's overloaded, but that's not the focus on this use case, sorry. So, but we see that the handling resource is currently in use due to the heuristics results. So from the cost perspective, on the demand cost, no change. We have raised the non-delivery and late delivery to a very high level in order to force the optimizer to plan something. Don't forget, if you have no penalty, no planning at all. Then we've got the transportation cost. And what we see is that from the LDC, from the factory to the local DC, then it costs not so much to transport. Remember the 1 IBP euro I've shown on the slide. The same for LDC2, that's for one product, but the same for the other product. It's the same for the other. Then to the regional DC, in my case, regional DC plays the role of the overflow warehouse. Therefore, here I say, it costs you that much to go from PP01 to the plant to the regional DC. It costs you about 1,000, exactly 1,000 per period, okay? Then from the RDC to the final LDCs, as well 1,000. So meaning you get 2,000 to 2 times the penalties if you are using the overflow DC, which does not mean the system will not use. It's just preventing the systems to use by default the RDC flow from factory to RDC and then to LDC. What we want is the standard is PP01 to LDC1 and 2 by default. On the other hand, we have inventory cost. It's not so much of an issue here, except that I have a very high cost on the factory because I don't want to store anything on the factory. Okay, I've got no space, for instance. Again, the production cost is still prioritizing production version number 1 with a very minimum cost, just to force the system to use only 1 instead of 2. Okay, just to have, in fact, a limit in production. And this is about it, about the cost. Now, continuing with this scenario, you have to maintain a lot of master data, as I've mentioned. So if we check here the storage handling resource, because we need the storage resource to be considered in this scenario in order to limit the replenishment on the local DCs. That means you need to maintain the resource. And in the model, due to the SCM labs, we see that we have some easy reading elements like storage space, storage types, location resource, where you define the combination with resource and location, and you have to maintain the resource location product. And we see that here for our product, we are using the storage or the handling, or both, of course, in each of our 4 locations. You see, it's a long way to go before you have the proper data setup to run. And okay, now we are finished with the preparation. Let's see in the system what happens when we do use the optimizer. So for that, I return to the capacity, production capacity. Yeah. On the production capacity, this is currently the heuristics result. Let me run the optimizer. Now we see that after the optimizer, now we have a nicely leveled capacity profile here, which is covering all our requirements. To some extent, it had to use also a little bit the alternative resource because the cost equation was made as such that it could afford to use this expensive second resource. Fine on that. Then let's save the result. And let's check now the result in terms of inventory to see where the inventory has been placed by the optimizer. So I am here in the inventory prior to the optimizer. Now let's refresh. And now we see that the inventory position, depending the different locations, has changed. First, what we see, no stock on the factory. Perfect. That's what exactly I wanted. Then what I see is there is a little use of the inventory on the local DC. Yes, because there is a storage capacity and up to the limit of this one, then the system allows itself to use it. And we also see that during the peak periods, it's about here 26, 27, the system is largely using the capacity, therefore the inventory position arrays on the regional DC, which we decided to be the overflow DC. Overflow Warehouse. So we see that it's nicely working. It's a lot of preparation, okay, of course, but in some case, this is really worth to go, like in the water business. I remember some Nestle case in Italy and Spain where we had to use this kind of organization. And that concludes this use case about outsourcing some storage space. Just before closing this chapter, let's go also on the capacity, on the logistic capacity view. So from here, from the handling, there should not be so much of a change. Of course, the number will change because everything has slightly moved over the period. Here it is. We see that that's moved, but still used. What we also see that storage capacity should not exceed 100% on LDC1 and LDC2. And it's exactly what it is happening here. Okay? And there is no issue with RDC because I've placed the RDC capacity to such a level that it could afford storing a lot. Probably even here I was limited by the number. Okay? So we see this is nicely working. Cool. Let's go. We are finished now. We are at the end of this use case presentation. You know what? You are now the expert capable to do the necessary setup to organize in your time series optimizer at home your own Overflow Warehouse scenario. You may have noticed that I've got different shirts on every scene. It's just because it takes me days to do that kind of episode. And I fancy doing it. Next time we will see prioritizing demand in the optimizer, how by means of penalties and other elements can we further prioritize the demand and give more weight to such type of customer, for instance, versus other customers by means of optimizer capabilities. In the meantime, if you like that kind of episode, please think of a like or even a subscription. It's all my salary for such exercise. Bye now.